Hey kiddos, this is going to be a long recording. So what I'm going to be doing is reviewing the practice test for Unit 2 with you so that you can use it to study from and figure out maybe what mistakes you're making. So what I would suggest you do in order to be ready for this recording is to have paper out and something to write with so that you can copy down any of the information that you want and then use it to try and find mistakes that you might have made, okay? So I'm gonna go ahead and start sharing my screen. All right, so at this point, you should be looking at the Unit 2 practice test questions, and I'm gonna go over how to do all of these questions with you. A few notes ahead of time. Number one, when you are taking the practice test or the actual test, you want to work the problems out. You definitely want to take the time to actually attempt to do all of the problems. And then you can look for the answer that matches. You certainly are encouraged to use logic and to eliminate answers that you know it can't be. And I'll be talking about that strategy or those strategies as I show you how to do this stuff, okay? But math is not a spectator sport. It is not something that you just look at and guess. You should actually be attempting these problems. All right, so the other thing that I want to remind you of is Desmos. You should definitely be using your Desmos calculator to support you as you are working. And you can also use your slideshows from It's Learning. So if you click on Scanlon 7th Math, and you look on the right side of your screen underneath the Zoom links, you're going to see other links. And if you scroll down to where it says Unit 2 slideshows, you can use these as you are testing or preparing for your tests. Okay, so I definitely recommend that you open up these slideshows and have them available to you as you are working. All right, having said all that, we're going to go ahead and get started going over these questions. So let's begin. Question number one. Which expression is equivalent to, and then they give you this math problem. So on all of these problems, we're always in the back of our head going to be remembering our order of operations, which is, please excuse my dear Aunt Sally, remembering that P is for parentheses. We're really not going to be seeing any exponents this year, so we can kind of forget about that for now. And then multiplication or division, whichever one comes first from left to right. And then finally, any addition or subtraction, whichever one comes first from left to right. So this is just going to be hanging around in our brains as we are working. And we're also going to use a couple of other strategies for this problem. The first thing I'm going to do is I'm going to write it out. 5.3x plus 2.8. And from that, we are going to add negative 3.8x plus 7. All right, so you were taught two different strategies on how to do this problem. The first strategy was what we called the stacking method, where we're going to line these problems up one on top of the other. And we're going to try to make sure that we're putting our like terms, the terms that have the variables, right on top or below each other. Okay, so to 5.3x plus 2.8, I'm going to add to it negative 3.8x plus 7. And I'm going to make sure on the 7 that I'm going to line up those decimal points. Right, when we are adding decimals, we're going to add up, line up the decimal points, and I'm going to add in a 0.0 just to keep things in the right place. All right, now that I've got it written this way, I'm going to go ahead and add these going down. So I'm going to take 5.3x and subtract 3.8x from it, because that 3.8x is a negative number. And so I'm going to subtract them. I can't subtract 3 minus 8, so I borrow from the 5, make it a 4. 13 minus 8 is 5, and 4 minus 3 is 1. So I get a positive 1.5x, and then I'm going to add the next column of numbers together. I'm going to add together 2.8 plus 7.0. All right, so 8 plus 0 is 8, and 2 plus 7 is 9, and they were both positives, so my sign in between them should be a plus sign. So the answer is 1.5x plus 9.8. Okay, the other strategy that you were taught was called the horizontal strategy. All right, so I could do this same problem all in one line, and what I would probably do is color code. Okay, so I would be taking these numbers and I'd be color coding them to show myself which ones are alike and go together. All right, so I would say that the 5.3x and the negative 3.8x go together. And then I would say that 2.8 and positive 7 go together. And you always want to take the sign in front of the number. All right, so now I'm going to focus on the things that I've circled in red. So I'm going to combine 5.3x minus 3.8x. And you notice how I just used that negative sign in front of the 3.8 as a subtraction. A subtraction and a negative sign mean the same thing. All right, so I could do 5.3x minus 3.8x. I'm still going to get 1.5x. And again, if I wanted to use Desmos to support me, I could do that. I could just plug in 5.3 minus 3.8, and I could forget about those x's for now just to get the coefficients difference, right? The number difference. And then I could combine my numbers that are in orange together. And so I would do 2.8 plus 7. Again, the 2.8 is a positive and the 7 is a positive, so I just add them together. And that would give me my 9.8. And because it's a positive, a plus sign goes in between the two. Right? Either way, you're going to get the same answer. Again, guys, using Desmos is super important if your integers are weak. Let's go on to question number 2. All right, unfortunately, question number 2 is a select all that apply, which is always the most difficult type of problem. So I don't know if there's 1, 2, 3, I don't know if all of them are equivalent. So we've got to be really careful on this one. So let's just go ahead and start with the problem. It says -8 groups of 5y minus 9. All right, so again, like I said, we're always going to use our order of operations. And the first one is P for parentheses. So I'm going to look inside of my parentheses and I'm going to say, can I subtract those two? And after thinking about it for a minute, hopefully your answer is no. I can't subtract 5y minus 9 because they're not alike. The 9 doesn't have the letter y with it. If it said 5y minus 9y, then I could subtract them because they're alike. But it doesn't have the y, so I cannot do anything inside those parentheses. So the next thing I'm going to do is I'm going to try to figure out what I'm supposed to do with this -8. And because -8 is squished right next to those parentheses, that means to multiply it. So I'm going to take that -8 and I'm going to multiply it by 5y. So I'm going to write it as -8 times 5y. I use parentheses to show multiplication. You can use the times sign or the dot if that makes you feel better. All right, and -8 times 5 is -40. So -8 times 5y is -40y. I'm then going to take this -8 and I'm going to multiply it by the next term. And remember, the sign goes with it. So the next thing I'm doing is -8 times -9. And a negative times a negative is a positive. 8 times 9 is 72. Okay, and because I get a positive answer, the sign in between these two has to say plus. So my final answer is -40y plus 72. And I'm given A through F choices. So I have to look through every one of these and see which ones are equal to this answer. So we're going to look for the most obvious one, which is the one that matches it exactly, which is letter C. All right, they both say the exact same thing, -40y plus 72. The only other thing that I could do to this answer is to reverse my two terms. I could put the 72 up front and the negative 40y behind, because the commutative property tells me it doesn't matter which order I add numbers together, I'm going to get the same thing. So I could put the 72 up front, and because it's positive, that sign where I would normally write positive 72 just becomes invisible. And then I could subtract 40y from it. Okay, again, this is going to be used instead of as a negative sign, it's going to be used as a subtraction sign. So this would be the other way to write this exact same expression. Okay, and you can see that that answer is right here, 72 minus 40y. Now there is one other way I could write this. And I could take this expression and I could rewrite it as an addition. So instead of writing 72 minus 40y, I could write it as 72 plus the opposite of 40y, which is negative 40y. All right, but that expression doesn't appear here. It's not one of these answer choices. So that's those two, C and F, are the only two that are correct. All right, it's really important that you guys practice how to rewrite expressions in different orders so that you can identify which ones are equivalent. All three of these expressions are the exact same thing. I know they don't look it, but they are. Okay, let's go on to number 3. Okay, question 3 says, select an expression that is equal to this subtraction. So this one is probably one of the most challenging ones you're going to see. And I am going to show it to you in one specific way because I think it's the easiest way. In math, there's always more than one correct way to do a problem. But I'm going to focus on the strategy that I think is the easiest. Okay, so the original expression is negative 8x plus 4. And to that, I am subtracting from it 5x minus 9. All right, so the first thing that I want to do is I want to start out by trying to explain to you guys what is actually happening. I'm going to draw it out. So I have negative 8x's, and I'm going to represent a negative x by the color red. So I have negative 8x's. And I have positive 4. So I'm going to represent positives by blue. And because it's just a positive 4, I'm going to use marbles to represent 4 marbles. And from this amount right here, from this whole group, what I am trying to do is I'm trying to subtract 5 x's. Right? I'm trying to subtract 5 x's. Now, why did I make them blue? Well, because they're positive. I have positive 5 x's. Remember, in that first grouping, I have negative 8 x's. That's why the colors are different. And I also, in this second grouping, have negative 9. And I'm going to use red for those marbles because they're negative. So this is a really difficult thing for me to subtract because none of the colors match. If I had 8 blue x's and I wanted to take away 5 blue x's, that'd be really easy, right? I just erase 5 on each group and I'd be done with it. But because my colors aren't the same, it becomes really, really complicated. So I'm going to show you how I do this, all right? And then you're going to see if it makes sense. I need to subtract these 5 blue. And so in order for me to do that, I am going to have to add the opposite. I am going to add the opposite of 5x, which is negative 5x. Okay, so I am going to now, instead of taking away 5 blue x's, I am going to add 5 red x's, and that's because I added the opposite. All right, so to this group over here, I am now adding 5 red x's. All right, and so that has already been done. I've already added those 5 red x's or the negative 5 x's. And again, because the marbles don't match, I am going to add the opposite of -9, which is +9. So I am going to erase all of these -9 red marbles, and I'm going to instead trade them with blue. So now I have 9 blue marbles that I am going to add on over here. And so this now is my final answer. So my final answer is going to be, if I counted up all the red X's, I would have 13 of them. So I have -13 X's. And if I added up all the blue marbles, there would be 13 of them. So +13 because it's positive. So this is the correct answer. Now, guys, I know that that visual representation might have been a little confusing for some of you. Some kids don't do really well with seeing this visually done. So I'm now going to show you how to do it mathematically, okay? So what I would do is I would still start by adding the opposite. I would rewrite this problem as addition. Okay, let me fix it up a little bit. I erased a couple of things that I should have in there. All right, so this is the original problem. I'm going to start by changing it from subtraction into addition. And this is how it's going to look. I'm still going to start with -8x + 4. I don't do anything to that because that's what I'm starting with. But instead of subtracting this, I'm going to add the opposite of everything in the grouping symbols. So the opposite of 5x is -5x. And the opposite of subtracting 9 is adding 9. All right, now that I've rewritten it as addition, I have just shown you in the problem before this how to add these together. Remember, you have two choices. You could stack them and do -8x + 4, and then underneath it, you write -5x + 9, and then you can add them together going vertically. Or you could color code, right? You could say anything with an X, I'm going to call maybe red. I'm going to take the sign in front, and anything without an X, I'm going to circle in maybe blue, and I'm going to add those together. Okay, either way, you're still going to end up with -13x + 13. And if I combined my reds together, it would be -8x minus 5x or plus -5x, which gives me -13x. And then I would combine my blues together, which is 4 + 9. And that's still going to give me 13. And again, because it's positive, the plus sign goes in between. This is going to be one of the most challenging questions on the quiz or the test. Subtracting expressions is very complicated. Okay, let's move on to the next question. Question number 4. Which of the following correctly factors -18y + 2y minus 6? All right, so the key here is remembering what it means to factor. So remember that the opposite of factor is to distribute. They are opposites. So let's remember what it means to distribute, because that's the easiest way to look at this. So to distribute means to take the number that's sitting outside of a grouping symbol and to multiply it by everything inside of a grouping symbol. So 3 times 3x would be 9x. I just made this problem up over here on the right. And 3 times -1 is -3. All right, so that's called distributing. What we're going to try to do is we're going to try to take an expression that looks like this, 9x minus 3, and we're going to try to reverse the process. We're going to try to figure out how to write it as a number outside of a set of parentheses. And if you remember back into the lesson, what we did was we looked for the greatest common factor. The biggest number that's going to go into both of these terms. All right, so I'm going to focus that idea on the given problem. Now, guys, I know maybe you're thinking, hey, Scanlon, can't I combine together that -18y and that +2y? And the answer is yes, you can, But if you look at all your multiple choice answers, they did not do that in their multiple choice answers. They left those two like terms not combined together. They left them separated. Okay, so what I'm going to do is I'm going to take a look at these numbers, 18, I know it's negative, 2, and -6. And I'm going to try to figure out the greatest common factor of all three of those terms. Okay, so I'm going to leave the negative sign out of it. So 18y's factors are 1 and 18, 2 times 9, and 3 times 6. And then obviously the letter y is a factor as well. I'm going to do the same thing for 2y and for 6. Again, I'm ignoring the negatives. So the factors of 2y are obviously 1, 2, and y. And then the factors of 6 are 1 times 6 and 2 times 3. Okay, so because I'm looking for the greatest common factor, I'm looking for the biggest number that's the same in all three lists. And that would be a 2. All right, 2 is common. Now, y is common in only 2 of them. I have a y here and a y here, but I don't have a y here. So y is not what we would consider common. All right, so my greatest common factor in these three terms is 2. So once I figure out the biggest number that divides into all three, I write it down outside of my parentheses. And then what I'm going to do is I'm going to look at the first term and I'm going to say, what can I multiply 2 by? 2 times what gives me -18? Well, 2 times -9 gives me -18. So 2 times -9y would give me -18y. And I'm going to repeat that process for the last two terms. So now I'm going to say 2 times what is going to give me 2y. Well, 2 times 1 is going to give me 2. So 2 times 1y is going to give me 2y. And again, because that's a positive multiplication, 2 times +1, I can use that plus sign in between those two terms. And then finally, I'm going to look at this 2 and this -6. And I'm going to say to myself, 2 times what gives me -6? And that's -3. And I'm going to use it as a minus sign. All right, so now for me to check my work and make sure I did it properly, I'm going to go ahead and I'm going to now distribute this back into this grouping. And I'm going to make sure that I get what I started with. My target is to make sure that I end up with my original expression. So 2 times -9y is -18y. 2 times 1y is 2y, so plus 2y because it's positive. And then 2 times -3, this last distribution here, 2 times -3 is -6. Okay, and it matches. So I know I have factored it properly. Okay, so now what I'm going to do is I'm going to try to match this middle one up. All right, I'm trying to find this answer over in my answer choices. And the only one that is exactly the same or close enough is this one. The only difference is that it doesn't have the invisible 1 in front of the y. Remember, 1y and y mean the same thing. All right, so A is the correct answer. The other way to do this problem is to reverse the process. And this is good test-taking strategies. Because this process is so complicated, right? And many of you were watching that saying, there's no way I'd be able to do that. Well, let's look at it a different way then. Because this is multiple choice, I could start with the first answer. And I could say, if I distribute that 2, if I distribute this 2 into this grouping, will I get the original expression? All right, so I could do 2 times -9y and get -18y. 2 times +y is +2y. And then 2 times -3 is -6. And right off the bat, I'm going to see that those two are equivalent. So that is the correct answer. It's not a bad idea on a test to go through and make sure that none of the other ones are right, because that'll tell you you made a mistake on something. right? But the good test taking strategy would be to just go ahead and use your answer choices to work backwards and distribute. Remember, guys, at any time that you're watching this, you can certainly pause the video while you take down some notes. I'm going to go ahead and move on to the next problem. Question number 5. Judy's fruit stand earns a 75-cent profit for each peach that it sells and a 75-cent profit for each apple that it sells. Which expression shows Judy's total profit from selling peaches, P, and apples, A? All right, that's a big mouthful. Let's take a look at that one again. Judy's fruit stand earns 75-cent profit for each peach that it sells and a 75-cent profit for each apple that it sells. Which expression shows Judy's total profit from selling P peaches and A apples? So if they weren't asking about profit and they were just asking for a total, we could take the number of peaches, P, plus the number of apples, A, and that would give us our total amount. Right? But they are asking us for a profit, and a profit means money. How much money did she make? All right, so to figure that out, what we would do is we would multiply the number of peaches. Let me write this down for you. We would multiply the number of peaches by 75 cents each. Right, so if she sold 1 peach, she'd earn 75 cents. If she sold 2 peaches, she'd earn $1.50 and so on. And so the easiest way to figure that out is to just multiply, right? And here's the other thing. She's going to earn the exact same amount for the number of apples that she is selling. All right, so because she is multiplying the number of peaches and the number of apples by the same amount, we could just group these two together and we could multiply it by that 75 cents. All right, so we could multiply the 75 cents times the number of peaches she sold and the 75 cents times the number of apples she sold, and then we could get our total expression. The other way we could write that is 75 cents times the number of peaches, P, and plus 75 cents times the number of apples, A, and that would give us our total. So this expression would represent her total, and this expression would also represent her total. Now I just need to see which one appears. So this expression is confusing. I am not adding 75 cents to the number of peaches she sold. I am multiplying them. So this is close, but it is incorrect. Right? So the correct answer is B. Go ahead and pause the video and take down some notes. I'm going to move on to question number 6.